Hi, welcome to our STEM video. My name is Tyler Wilson. I'm an acoustic summer placement.
Hi, my name is Michael. I'm also a summer placement here at AECOM.
Hi, my name is James Morfield. I'm a graduate acoustician here at AECOM, and welcome to our video on Helmholtz resonator.
Have you ever wondered why when you blow over the top of a bottle it produces a loud note, and that this note is different for different sized bottles? This is due to an acoustic phenomenon called resonance. Resonance is a very powerful phenomenon that acousticians like us think about a lot. It needs to be avoided to make sure that excessive vibrations don't build up. An example of unwanted resonance is the oscillations that were produced by pedestrians walking over the Millennium Bridge in London when it first opened. Resonance is so powerful that we'll be able to make bottles move by just playing a sound.
A Helmholtz resonator is a container of gas with an open hole. A volume of air in the neck vibrates because of the springiness of the air inside the chamber. The chamber acts in a similar way to a spring, and the neck will act like a mass attached to the spring. The frequency of this resonance will depend on the volume of air in the chamber, the opening area, and the neck length. In this experiment, we play a sound at the same frequency as the resonance of the bottles. The bottles like to vibrate a lot at this frequency, and they will start to resonate. This causes the volume of air inside the bottle to compress and expand, forcing air out of the open top and causing the bottles to rotate.
To carry out this demonstration, you will need a speaker with a fairly large diameter, as small speakers aren't very good at producing low notes, two identical drinks bottles to act as Helmholtz resonators, something light to connect the resonators, something to attach the resonators in opposite directions, something to balance the resonators on. We use a drawing pin attached to a stand. First, you need to find out which frequency your resonators will resonate at. To do this, record the sound of air blowing over the top of your bottles with your phone. Next, import this file into an audio editing software. A great program to use is called Audacity. It's free to download. Once you've imported the audio into Audacity, highlight a section of the sound and click on Plot Spectrum. This is a Fourier transform, which is a mathematical equation that acousticians use to convert a signal from the time domain into the frequency domain. You can see here that the most amount of energy is at 202 Hz. This is the resonant frequency of the bottle. Use the free app, play back a tone at the frequency through the speaker at the bottles.
Here you can see that the sound has the power to make our bottles move without anything touching them. In fact, the bottles will not spin at any frequency other than their resonant frequency.